Hello. Okay, guys. Well, morning, everybody. Thank you for coming to the session today. So, as I said, I'm from Microsoft. My name is Richard Warner, and I head up the networking partnerships across EMEA. So we're really happy to be here, especially on the back of the fact that we've recently announced that we're actually going to be building data centers in South Africa. So really bringing the cloud to you guys locally, and looking forward to that. So today we're going to talk really around the importance of networking in the cloud and how connectivity is absolutely key for when customers are taking on their cloud journey. And obviously the audience here, it should really resonate with you guys as well, being networking from the networking area. So let's see. So one of the biggest things we're seeing in businesses is that we're seeing a lot of organizations adopt what we call digital transformation. And really what digital transformation is it's where you're taking your old analog processes and really digitizing them. And great example of this is how do you better engage with your customers using digital transformation? And this is a really interesting example of how this actually happens. So in Japan, there was a small noodle bar, and they were struggling with engaging with their customers, or struggling to get business. So what they actually did is they used the power of the cloud and the democratization of the cloud to actually build a bot, which is basically a piece of software. And they used Cortana, and they actually installed it in a robot. And so when customers came into their noodle bar, the robot recognized the customer's face using face recognition technology from Microsoft. And they could tell if that customer had been in, and they could also tell if that customer what they'd ordered. And they could also then link into that customer's Facebook page and tell if it was their birthday, and offer them different promotions and different types of noodles and all of this kind of interesting stuff. And this is a really simple example of digital transformation in action, because they've taken analog menus and a very sort of old school way of serving people, and then they've incorporated things like AI, bots, and all of the power of the cloud, and they're just a tiny little business. And because of the cloud and the democratization of it, and you only pay for what you use, it enabled them to do this and deliver this new and innovative way to speak to their customers. But obviously, as you move more stuff to the cloud, there's obviously this challenge of, how do you get to it and connect to it in a performant manner? So this is why we start with what's the challenge. Now, these are just quotes from different analyst houses and networking magazines. And I won't read all of them, but as you can see, the melody line is, like the number one challenge that customers are finding in adopting the cloud is networking issues. So they're worried about whether they're going to get the same type of experience when they connect to their on-premise infrastructure as they do when they connect to the cloud. And we listened to this, and we understood that more customers are saying our application performance is only as good as our network. So how can we help as Microsoft deliver that better experience? Also, we did some research to kind of look into this in a bit more detail, and we sort of asked customers. We said, how many workloads do you have in the cloud today? And how many more workloads would you put in the cloud if networking issues were resolved? And as you can see, there was almost a 68% increase in the actual adoption of workloads in the cloud if those network issues were resolved. And then the quote on the right-hand side is actually from our CVP of networking. So he runs our whole network globally, and he said that you cannot have a first-class cloud without a first-class network. So again, we really focused in Microsoft about building a network and ensuring that we've got a great network for our customers to consume our services. And there's a real opportunity for partners, and we work a lot with partners, and we'll go into a little bit more detail, but we work with a lot of the large telcos and carriers to deliver that network to our customers. So what's the solution? So this is a slide which really outlines the kind of investment that we're putting into delivering services globally. So we've got network partners in 130 locations now. We're doing 72 terabits of data, not including metro. We've got sort of 1.65 million servers per region. Huge numbers that we are delivering today over our infrastructure. And I think this slide represents it a lot more. These are all of our data center regions across the globe, and we've really focused on bringing the data centers closer to the customers so that they can actually connect to our servers in a much more performant manner. And we're obviously, as we move into areas like Africa and places like India and the emerging markets, we're really focusing on working with the local carriers and the local partners to deliver these solutions to our customers, especially the network guys, and that's really where we come in and why we're in Africa at the moment. Another really interesting thing is that we've not just invested heavily in data centers, but we've also invested heavily in data centers in regions where compliance is absolutely critical. So areas like China, we've built actual government clouds that are isolated. So for our customers in China, they can still connect to Azure, and we've done the same in Germany to make sure that we can adhere to local compliance regulation. Really, this just demonstrates the size of the network and the actual depth and detail we've gone into delivering services within all the regions across the globe. An interesting stat is I think we're now the third largest network in the world, and obviously we work with partners to deliver that, but in terms of size, we are actually the third largest network in the world. So we've obviously built the infrastructure, but then we wanted to also focus on different ways that our customers could connect to the cloud, because we appreciate that there's a number of different customers, sizes, the price points that they can obviously achieve. All of those things are important to us. So really we've got kind of 4 fundamental products that help customers connect. So number one, obviously everyone knows, there's the internet. And where we see this is mainly our consumer customers using the internet, and fairly straightforward, low-level activity in Azure, that kind of thing. Then we have, secure point-to-site, connectivity, and secure site-to-site VPN connectivity. And this is where customers are taking that next journey. They're looking to do more in the cloud. They want to have IPsec. They want to ensure that they've got a better, more secure connection to the cloud. And they're starting to do a little bit more on their cloud journey. So their cloud journey is evolving a bit more. They're probably doing some POC or sandboxing in Azure. And then the final solution, which I want to go into detail today, is really ExpressRoute. Now, ExpressRoute is our kind of, if you like, our Rolls-Royce of connectivity products. And this is really where we're seeing organizations who are looking to take that next level into cloud, who are really looking to deploy advanced workloads, mission-critical applications in the cloud, taking their the products that they were using on-premise and actually fully moving them into a cloud-based solution. So again, mission-critical workloads, things like HPC, high-performance computing, these are some of the examples where we see people looking to take ExpressRoute. And the reason why I want to focus on ExpressRoute is because this is where we really work with partners and connectivity providers across the globe to deliver these services. So really, what is ExpressRoute? And I'm not going to go into too much detail on the technical stuff because Federico is going to cover that, but just very high level. You've got the customer's network on the left-hand side in the light blue cloud. In the middle, there's what we call the ExpressRoute location. And then basically you need, as a customer, to get to the ExpressRoute location, you hand off the data to us, and then we then take that data across our backbone to the data center of choice. So interestingly, when you connect to us, you don't actually connect to a data center location, you always connect to a peering location. So, for example, in Europe, you would connect to our peering location in Equinix, which is in London, and then we then take that data across our backbone to the customer's data center of choice, whether they want to choose to put their data with us in Amsterdam, in Ireland, etc., etc. But really, the key about this is that you do not need to go over the public internet with ExpressRoute. It's a dedicated connection from your network all the way into our network. So why is that important? Well, the real value proposition is predictable performance. You guys are all networking professionals. You know that the internet, one day you can get a very good latency speed, but it could be congested. So the next week, you won't get such a good latency speed. Now, really, the fundamental value proposition here is the predictable performance. So with ExpressRoute, because it's dedicated and you get that dedicated bandwidth, you're pretty much sure that when you send a packet data on a Monday, you'll get a latency speed of, say, hypothetically 10 milliseconds. You're pretty much sure that on the last Monday of that month, you're going to get 10 milliseconds. With the internet, you could get 7 milliseconds on the first Monday and 70 on the last Monday. Now, obviously, that has a huge impact if you're a business and you're using the cloud and you want to know that when you're sending information, say you've got your front end is in Azure, and then the back end where you do all the compute is in your data center, you want to know that when those two talk to each other, you're going to get a performant and reliable response from those two applications. So it becomes very, very critical for businesses who are looking to move from a POC environment to a production environment to have that predictable performance. One of the other things that's really valuable about ExpressRoute is that obviously you get an SLA. So obviously with the internet, there's no SLA. And this again becomes very critical for big corporations, banks, those sort of guys who are really looking to have that kind of enterprise level style agreements and meet compliance and regulation that they need to talk back to their legal team and so on and so forth. So they really want to know that they've got an SLA in place that can support those compliance and regulatory reasons. And then redundancy is also a key one for ExpressRoute. So when you buy one circuit, you natively get two. So again, very, very strong for businesses who want that extra reassurance around when connecting to the cloud. And the last one is high throughput. So it's interesting because I started coming to Africa about two years ago, and I would sit down with carriers and we would talk about ExpressRoute, and the first thing they would say to me is, what's the bandwidth for ExpressRoute? And I'd say, oh, well, the lowest one's 50 meg and the highest one's 10 gig. And most of the times they would laugh at me and say, is there nothing lower, you know? And I would say, oh, is this not low enough? And they would say no. So we actually said that, you know, whilst we charge, the lowest we charge is 50 meg, but our charges are very small compared to what a carrier would charge. You can go for 10 meg with your local carrier. So we've changed it a little bit. But what we see in Europe, and we even see it now in South Africa, we're seeing more customers taking 1 gig, 2 gig, even 10 gig. And that's what ExpressRoute enables you to do. So for example, as I mentioned earlier, one of the other services we offer is a VPN service. The VPN gateway has a restriction of basically 1 gig. So if an organization is really looking to do more in the cloud, they want to know that they can get that high bandwidth connection. And that's what ExpressRoute offers as well. So that was really me done. I wanted to give you guys a kind of flavor of why we're seeing connectivity as such a critical part of cloud enablement, and also understand some of our products and really the value around ExpressRoute specifically. Now I'm going to let Federico go into a lot more detail around how this works technically, talk a little about BGP and that sort of good stuff. So Federico, I'll hand over to you. Thank you.
Hello everybody, thanks for having us today. My name is Federico Guerrini. I'm an Azure technical specialist. I take care of networking for the Microsoft Azure platform across EMEA from a technical standpoint. My goal for today is to share with you some details about the ExpressRoute service that Richard introduced. So the key idea behind ExpressRoute is to allow our customers to connect directly into the Microsoft network without traversing any public networks. Of course, it is not possible for Microsoft to provide the last mile. We cannot extend our own network up to the front door of each and every customer. And this is the reason why we work with carrier-neutral facilities where we deploy edge routers connected to our backbone. And that is where we expect customers to come and to meet our network. So essentially, for an ExpressRoute connection to be in place, customers must extend their network from their premises to one or more carrier-neutral facilities where the express route service is available, assuming that they are not already co-located. The second piece is the carrier-neutral facility itself that, as I will explain later, simply provides a layer 2 switching fabric between the customer and Microsoft. And the third piece is, of course, Microsoft-owned routing equipment deployed at the carrier-neutral facilities and connected back to the Microsoft backbone. So ExpressRoute only provides layer 3 routed connections. We do not support layer 2 extensions into our network. So essentially, we expect customers to deploy their own routing equipment within a carrier-neutral facility and to get their routers cross-connected to our routers through a layer 2 switching fabric that is provided by the carrier-neutral facility. ExpressRoute leverages BGP. BGP is actually the only dynamic routing protocol that we support, and this is what we expect customers to be able to speak with us in order to exchange routing information between them and us. As Richard mentioned in his presentation, ExpressRoute is a highly available service by design. So what you see here is actually only half of the picture, and the full picture is this one. Every time a customer provisions or asks for an ExpressRoute connection at one of the available peering locations, Microsoft makes available 2 physical ports in that location, and we deploy a pair of routers in that location, which are connected to diversely routed links back to our backbone. If customers want to leverage that level of redundancy, they are expected to do the same. So they are expected to reach the peering location through 2 different links, and they are expected to deploy 2 pieces of routing equipment in it. So this is just a further clarification. In Microsoft terminology, when we speak about an ExpressRoute connection, we speak about a logical connection between a customer's network and the Microsoft network, which is implemented on top of 2 physical links going to the same peering location, that is to the same carrier-neutral facility. So we don't expect any customers to have enough networking knowledge within their organization to design, implement, and maintain the network configuration that I have just shown. So we give customers more choices, and we give customers the opportunity to work with a broad partner ecosystem to make sure that they can get help when they need it to get an ExpressRoute connection up and running. We refer to these options as deployment options. I have almost explained the first one, which is what we call the Cloud Exchange co-location option. So essentially, customers that decide to deploy ExpressRoute according to this model have to deploy their own routing equipment within a carrier-neutral facility from which we expose the ExpressRoute service. Of course, this would be the natural choice for customers that are already co-located at that carrier-neutral facility. If a customer is not co-located already, they can work with a provider of their choice to extend their network to that carrier-neutral facility. Then they can leverage the switching infrastructure provided by the carrier-neutral facility to get cross-connected to Microsoft. So, according to this model, there are 3 different areas of responsibility. The customer is responsible for extending their network from their premises to the peering location, assuming they are not co-located already. The carrier-neutral facility itself is responsible for providing a layer 2 switching fabric, and Microsoft is, of course, responsible for managing its own routing equipment in the carrier-neutral facilities and to make sure that those routers are connected to the rest of our backbone. In this model, customers are responsible for every layer 3 aspect of the network configuration. So they are responsible for defining the point-to-point networks that they want to use between their routers and our routers, and they are responsible for managing the BGP sessions that will be used for to exchange routing information between Microsoft and their network. As you can see here, everything is redundant in ExpressRoute, so customers are expected to establish two pairs of two BGP routing sessions in the same carrier-neutral facility, one for the primary link and the other one for the secondary link. According to this model, the cost structure for running and having an ExpressRoute connection to Microsoft includes three items. From a customer's perspective. Customers will be responsible for contracting the connectivity from their premises to the carrier-neutral facility if they are not co-located. Customers will be responsible for talking to the carrier-neutral facility and to actually buy hosting space from them, and also to ask for the cross-connects towards Microsoft. Of course, Microsoft is responsible for managing the connectivity back to the rest of the Microsoft backbone. So customers will see essentially three cost items if they decide to manage ExpressRoute this way. They will have costs related to the connectivity from their premises to the carrier-neutral facility. They will have to pay the fees to the carrier-neutral facility, and they will have to pay Microsoft for the consumption of the actual ExpressRoute service. So this level of complexity is simply not acceptable for some customers. What some customers tell us is we are not co-located and we don't want to manage any piece of routing equipment outside of our premises because our organization does not know how to do that. So we work with partners that essentially can remove this problem for customers. These partners provide two things. They provide connectivity from a customer's premises to the carrier-neutral facility, and they also take care of managing all the network-related aspects of cross-connecting a customer's network to Microsoft. So, in this model, customers will still be responsible for managing the layer 3 aspects of the configuration, but they will not have to deploy anything within the carrier-neutral facility. In this model, the BGP sessions will be established between routers within the customer's premises and routers deployed by Microsoft at the carrier-neutral facility. So essentially, according to this model, customers work with partners which extend the layer 2 virtual circuits from the peering location back to the customer premises. The cost model that results from this approach comprises two pieces. Customers will have to pay one fee to the partner, providing them with connectivity and interfacing them with Microsoft within the carrier-neutral facility, and customers will have to pay Microsoft for the consumption of the ExpressRoute service. The third option that we offer is for customers who already buy IPVPN services on top of MPLS backbone from leading MPLS providers, such as BT, Orange Business Services, Tata Communications, and so on and so forth. So essentially, these customers already have IPVPNs in place provided by these carriers, and the only thing that they need to do is asking their carriers to provide them with ExpressRoute access. What happens in this case is the providers will be responsible for establishing BGP sessions with Microsoft, a pair of BGP sessions for each customer, and to inject in each customer's IPVPN the prefixes that they learn from Microsoft. So according to this model, customers essentially see the Microsoft Azure platform just like one additional site being added to their existing IPVPN. In this case, customers are completely relieved by managing any network-related complexity. So the cost structure that results from this approach, again, is comprised of two pieces. There is the first cost item, which is the fees that customers will pay to their MPLS providers for managing Express Route access for them, and there is a second fee that customers will pay to Microsoft for the consumption of the Express Route service itself. One more thing that I want to mention on the technical side is that one single Express Route connection can be used to consume three different types of services or three different families of services within the Microsoft network. The first type are the cloud services which Microsoft collectively refers to as software as a service solutions. The most famous service in this family are the applications within the Office 365 suite, such as Exchange Online, SharePoint Online, and so on and so forth. These services are essentially exposed over the public internet by Microsoft. The application endpoints of Office 365 applications use public IP addresses which can be reached by anyone with an internet connection. So in this case, Express Route just becomes a different way to route traffic to Microsoft. Instead of using the internet, Express Route customers can reach the same endpoints by using dedicated lines and entering directly the Microsoft network. The second family of services that can be consumed over an Express Route connection are the so-called Azure Public Services. Azure Public Services are services provided by the Microsoft Azure platform, such as storage, machine learning, media services, and so on and so forth. Again, these services are exposed by Microsoft over public IP addresses, and as such, they can be consumed over the public internet. Again, Express Route just becomes a different way to route traffic to the Microsoft network, a way that, as Richard mentioned before, aims to provide more stable and predictable performance to customers. The third family of services that can be consumed over an Express Route connection are the so-called Azure Private Services. Azure Private Services are services which live in isolated networks with IP address spaces which are customer defined. So those networks are not exposed to the public internet by Microsoft, and some sort of tunneling technology is required in order to enter those networks. For customers that decide to use the public internet, that tunneling technology is obviously an IPsec VPN. Express Route is a different option which relies on a different tunneling technology, GRE more specifically, which allows customers to enter the Microsoft network over dedicated lines and privately connect to their virtual networks for which they are free to define the address space that they like. So in order to support this, every time a customer provisions an Express Route circuit, Microsoft makes available 3 different VRFs for that customer, each one managing the BGP sessions for the corresponding routing domain. So there is a VRF instance for the Azure private routing domain, there is a VRF instance for the Azure public routing domain, and there is a VRF instance for the Microsoft Office 365 routing domain. As I mentioned before, the Azure private services live in private IP address spaces which are completely defined by the customer. Because of that, we cannot simply take traffic coming from the customer's networks and route that traffic over our backbone, because of course we would have IP overlapping problems. This is the reason why traffic over the Azure private peering is encapsulated in a GRE tunnel. Of course, this is not a need for the other two for the other two connections, for the other two peerings, because those peerings are essentially related to accessing services which are already exposed by Microsoft behind public IP addresses. In order to allow customers to leverage the same physical links to consume all the 3 families of services, we allow us to deliver to us 3 VLANs over the same trunk. So every time a customer orders an extra short circuit, they can only deploy one physical connection and then define up to 3 VLANs over on top of that physical connection. And then it is their choice whether to configure one VLAN, because they only need to access one service family, or all the 3 VLANs in order to consume all the available services. The 3 VLANs can be defined either by using .1Q or Q-in-Q encapsulation. That is I'm done. Thanks. This is just a customer choice. This was actually my very last slide. So with this, I thank you again. And if you have any questions, I'll be around, so I will be happy to take them offline. Thank you again.
Federico and Richard, really appreciate your attendance. I'm not sure if it was 100% well targeted. I'm very interested personally about the South Africa West and South Africa East. What made you call it West and East rather than Joburg and Cape Town?
Well, we always that's how we always.
And I assume that this is NAP Africa, Joburg and Cape Town.
Couldn't possibly say. No, that's just our naming conventions. We always call it like
You can't possibly say if they're in carrier neutral location. Which one they are?
No, we're not allowed to divulge that at this stage.
Oh. I think we can work that out.
Yeah, I'm sure you guys might have an idea.
Does anybody here use any of these sophisticated services to connect to Azure, or do you just use like standard IP? Is everyone using standard IP to connect to Microsoft Azure, data centers, cloud? I have customers that use it. It's a big school. They have about 2,000 kids. But thankfully, they haven't come up with any of the ideas that you tried to express here. I'm very happy that you were telling us as ISPs about these ideas that you tell our clients rather than going to our clients directly. Anyway, we don't have really in many times, unless anyone's got a really pressing question for Microsoft, for Federico or Richard. I'd like to